Tonight on Catalyst.
Working in this field has really been a roller coaster ride. Thinking you understood something and then realizing you're completely wrong.
What happened in the cosmic dark age when the very first stars and galaxies were formed?
Gamma ray bursts are the most extreme objects we so far discovered in the universe. They involve more power. They probably are the places where black holes are newly forming.
The conclusion to one of the great mysteries of science. Hello, I'm Karina Kelly. We're taking a break from our regular program to bring you the final part of a special report. It began with the search to discover the origins of the most powerful explosions in the universe. Tonight, the search for the Death Star takes us on a journey to the most bizarre objects in space, black holes. They hold the secret to one of the great mysteries of science, how the very first stars were born.
Explosions of inconceivable power are tearing through the universe hundreds of times a day. Something out there was causing huge explosions, blasting out deadly gamma rays. If the bursts were coming from beyond our galaxy, then they had to be caused by something far bigger than science could explain.
If they were really coming from distant galaxies, it was a phenomenon unlike anything we've seen before. The amount of energy release, the rate of energy release was greater than anyone had ever seen before in any other form. And the details of how you got that, nobody could understand how that could be. It was pressing the limits of our understanding.
It was now clear that these explosions were of an almost inconceivable size. So big, in fact, that they might even be violating Einstein's fundamental law, E equals mc squared. And that was meant to be impossible. It now became imperative to get an accurate distance measurement of the gamma ray bursts. Scientists turned to the only technique they had for precisely measuring how far away objects are from Earth. A technique called redshift.
Redshift is a fantastically important tool for astronomy. Basically, measuring the redshift to an object is what tells us the distance of that object in astronomy. And the distances that we're talking about are so vast that they're extremely hard to measure by any other way, but redshift actually turns out to be quite straightforward.
Most explosions cause a flash of visible light. Scientists can split this light into its spectrum of colors. The further away an object is from Earth, the more red the light looks. The problem with gamma ray bursts is that they produce no visible light, so they cannot be redshifted.
Even today, we cannot focus gamma rays. There are no lenses that will make an image in gamma rays.
But then they realized that when the gamma rays blasted out, they would pass through all the gas and dust floating in space. This material would be heated up and would glow. This afterglow would be visible and might last for several days. If they could find it, it could be redshifted.
If we could ever find just one glowing ember of a gamma ray burst, the mystery would be cracked open, because we'd have a location and we could go look with the full panoply of radio telescopes and telescopes in space and big telescopes on the ground.
The hunt was now on for the afterglow. There either. This light was so far towards the red end of the spectrum that the burst could only have come from further away than anyone ever imagined.
Redshifts proved conclusively, beyond any doubt, that they were coming from the edge of the universe and nowhere nearby.
So the gamma ray bursts were coming from the other side of the universe, 10 billion light years away. No star could be big enough to produce that amount of energy.
If you took all of the stars and all of the galaxies and all of the quasars and everything in the universe and put them all together at one point at the distance of a gamma ray burst, it would not be as bright as the gamma ray burst.
It meant that they were being produced by explosions that didn't just test Einstein's law to its limits. They completely shattered it.
The amount of power involved to produce a bright flash detectable literally 10 billion light years away was a remarkable source of energy and remarkable phenomenon that we really had to try and explain.
Scientists were stunned. Now they were confronted with something that was physically impossible.
What was mind-boggling was how that much energy is converted into gamma rays. Because the amount of energy was so large that people felt, my goodness, maybe new physics is required.
For a brief moment, it seemed that E = mc squared was wrong. And if a law as fundamental as that was wrong, then perhaps everything we understood about the universe could also be wrong. Someone had to restore order. The man who came to the rescue was one of astronomy's heaviest guns. Martin Rees is nothing less than the Astronomer Royal.
Physicists always like to observe places where the laws of nature are, as it were, being tested to breaking point, because then we will see how robust those laws are, perhaps discover something new. And the most exciting parts of the universe, from the point of view of a physicist, are the places where the most extreme conditions prevail. And I think there's a clear consensus that the gamma ray bursts involve the most extreme physics we know about.
Rees realized scientists had always made one assumption when calculating the size of the bursts. Explosions normally spray out energy in all directions. So scientists had assumed that what we saw on Earth was just a tiny fraction of the overall energy produced by the explosion. And there lay the problem.
If they really were emitting energy over the whole sky, not just in direction toward us, would involve so much energy that that would violate Einstein's E = mc squared.
But Rees is an expert in the most bizarre objects in the universe, black holes. A black hole is created when a star burns up all its fuel and dies, collapsing in on itself. They have such immense gravity that they swallow up everything around them. And as they do, they throw out pure energy in two powerful jets. Rees believed that the same process was at work with the gamma-ray bursts.
If it were the case that the gamma-ray burst energy is coming out not in all directions around the explosion, but is channeled in a particular narrow beam or jet, then it means that the total amount of power coming from a single object is less than it would be if it had to radiate over the whole sky, because there'd be a sort of searchlight beam coming towards us.
It would mean the energy we were detecting on Earth would be almost the total energy produced by the explosion.
It doesn't take nearly as much energy if you can shoot the light down a gun barrel and shoot it right at the observer. Then you don't have to waste energy in other directions. We call this beaming.
Using Rees's theory, they recalculated the size of the explosions and found they were now well within Einstein's limit. There was a way gamma-ray bursts could come from the furthest edges of the universe and still not break the fundamental laws of physics. But Rees's theory did something else. It gave scientists the first clue to what might actually be causing these mysterious explosions. It had to be something to do with stars dying and the black holes they then create. What no one could have guessed was that the true wonder of these gamma-ray bursts was yet to emerge.
Working in this field has really been a roller coaster ride, you know, thinking you understood something and then realizing you're completely wrong, and then having it turn out to be, for me, one of the most exciting phenomena in the universe.
It would be a phenomenon that could allow science to reach back to the cosmic dark age itself. The chain of events that was to reveal it all began on the 22nd of February, 2001. Telescopes around the world picked up the second most powerful gamma-ray burst ever detected. Data started pouring into the Very Large Array in New Mexico, the world's largest collection of radio telescopes. In charge was Dale Frail.
After one of these bursts goes off, there's a mad frenzy of phone calls around the world trying to capture the burst. The earliest evolution of these events is very important to us as astronomers, so that we get on the phone to grab as many resources as we can around the world while the source is rising. And in this particular event, we were able to get on within a few hours of the event.
As Frail analyzed the pattern of radio waves that accompanied the burst, something struck him. Usually, in an explosion, the energy blasts out, reaches a peak, then fades to nothing. But that's not what Frail saw.
What we'd expected to see is something rising, reaching a maximum, and then fading away with time. But to our complete surprise, what we found was a signal much stronger than we expected to see. and it stayed constant during the entire time we observed it. In fact, it stayed constant as far as we know up to this day.
Frail couldn't figure out how an explosion could give off a constant stream of energy long after it should have disappeared. And then he realized he wasn't just looking at an explosion, but at one of the wonders of the universe. There is only one type of place known to emit a constant radio signal like the one Frail had seen. Star nurseries, the places where new stars are born.
They are stellar nurseries where new stars are being born on a daily basis. Brand new stars every day.
Star nurseries are found in all galaxies. They are one of the most extraordinary things in the universe. They consist of huge clouds of gas and dust, hundreds of light years wide. Inside these clouds, the pressure is so great in places that hot, dense clumps form. These get so hot that a nuclear chain reaction starts, and the clump of gas ignites, becoming a star. It was these star nurseries that seemed to be producing the gamma-ray bursts.
The detection of a gamma-ray burst inside one of these stellar nurseries points inevitably to the idea that gamma-ray bursts are somehow connected to this process of star forming.
But this just didn't make sense. The theory was that the gamma-ray bursts were caused by black holes, the result of stars dying. So why were they coming from the places where stars were being born? The person who was to bring life and death together was Stan Woosley, a man long obsessed with things that go bang.
I've always loved explosions. I loved fireworks. I loved to put together chemicals of different kinds that you can't get anymore and make little bangs when I was a kid, safely away from people. And the idea that the gamma-ray bursts turn out to be just the biggest bangs in the universe is just a real thrill.
Woosley's aim was to work out how a star could die while still in a star nursery. Most stars live for around 10 billion years. Only then, long after the nursery has disappeared, do they die. But Woosley worked out that if a star was to grow to an enormous size, what he called a massive star, then the whole cycle of life and death would be accelerated. A massive star would burn up all its fuel so quickly that it would live just a fraction of a star's normal life.
Now, a star that has 10 or 20 times the mass of the sun will have a much shorter life. It has more mass to burn, but it burns its fuel very rapidly. It's the fast livers of the stellar lane.
It means these massive stars would die while they were still very young, still inside the star nurseries.
These big stars die very close to where they were born. And this means that if gamma-ray bursts are coming from massive stars, as we suspect, gamma-ray bursts, which are the deaths of these stars, should also be occurring in regions where stars are being born. So this is a clue about what makes the gamma-ray burst, the prediction.
Using his theory about massive stars, Woosley put all the pieces of the jigsaw together. And he came up with a theory that explained everything. It was given the name Hypernova. It all begins inside a star nursery with the formation of a massive star. The star then burns furiously, using up all the fuel in its core, in just 1 million years. It then collapses in on itself, becoming so dense, a black hole is formed. It sucks in all the matter that once made up the star. Out of the black hole burst the gamma-ray jets. A hypernova is formed, releasing gamma rays in 2 tightly focused beams. It means that every time we see a gamma ray burst, we are witnessing the death cry of a massive star and the birth of a black hole. The mystery of the gamma ray burst was solved.
Gamma ray bursts are the most extreme objects we so far discovered in the universe. They involve more power, more intense radiation than we found anywhere else. They probably are the places where black holes are newly forming.
But now it seems there's one final twist to this story.
The gamma ray bursts were astounding when we first discovered them. They've become even more astounding that we know how far away they are. And now they're opening up a new window to the distant universe.
Some now think that the gamma ray bursts may solve the problem that has defeated scientists for so long. What happened in the cosmic dark age?
One of the big challenges of observational cosmology at the moment is to try and push our observations as far as we can into that dark age period to see really when the very first objects like stars and galaxies formed.
The reason why scientists are so desperate to find out how those first stars were formed is because they hold the key to the big mystery of creation. Scientists knew that all the elements that make up the universe, the galaxies, the planets, even the air we breathe and the bones in our bodies, were all first made inside stars.
Everything, including the elements that you and I are made out of, has been made as a product of stellar evolution.
This is how the heavier elements are formed. So the iron in your blood came from the center of a star. We really are stardust.
Without stars to make all the elements, there would be nothing. Because when stars die, they explode and scatter their stardust across space. It then becomes a crucial part of the dust and gas that form the next generation of stars. But the mystery is, if the stars make all the elements, then what made the very first stars? The answer has to lie in those cosmic dark ages at the dawn of time. What scientists have now realized is that the gamma ray bursts may be a way of seeing into those dark ages. We now know these explosions happened billions of light years from Earth. That also means they happened billions of years ago. It has taken all that time for the light to reach us. Scientists now hope that the beams of gamma rays will act like a torch that will guide their telescopes through the darkness. They know that the bursts are guiding them directly to star nurseries. The hope is that they may one day find bursts from the very first star nurseries, where the very first stars were made.
The first gamma ray bursts may be connected with the very first stars, and if so, they allow us to probe what happens in the stage of the universe when it's just coming out of its dark age, as it were.
No one has yet seen a gamma-ray burst from the Dark Age. The oldest we have is from 10 billion years ago, but earlier ones must exist. It's now just a matter of finding them. And then, when we do, finally, we will learn how the universe, as we see it today, came to be.
Well, that's the end of our special report on the Death Star. Next week we'll return to the regular Catalyst lineup when we take you into the heart of a battle over how to manage our koalas.
The most cost-effective and simplest way to do it is to shoot the animals.
Is science being held hostage to emotion?
I believe our tourist industries would suffer, I believe our image would suffer, and not to mention the koalas would suffer.
And the stem cell story you haven't heard yet. That's coming up next week on Catalyst, Thursday night at 8 o'clock. I hope you can join us. Till then, good night.